Hello and welcome to Manage and Modularize Tasks and Templates and Multi-Stage YAML. I'm Andrew Conniff, a Microsoft technical trainer specializing in data and AI, and we have some exciting topics to cover, so let's get started. Task groups in Azure DevOps are a powerful way to simplify and standardize our deployment process. So think of task groups as a reusable bundle, a sequence of events that we can encapsulate and use across multiple pipelines. By parameterizing these groups, we make it easy to adapt them to different projects and environments, saving a lot of time and reducing errors. This approach allows teams to centrally manage deployment steps, ensuring that every application follows the same best practices and compliance requirements. So an example, you might create a task group for deploying a web app, then reuse it for different projects simply by changing a few parameters. Variables in release pipelines make our deployments flexible and secure. In Azure DevOps, we can use predefined variables, pipeline variables, stage variables, and variable groups to store and manage variables or values that our pipeline needs, such as server names, passwords, or environment settings. These variables can be normal or secret, with secret variables providing an extra layer of security by hiding sensitive information like passwords from logs and unauthorized users. In classic pipelines, we can use the same variable in each stage with different values by assigning the scope of the variable. In YAML, it may be more efficient to use named variables for each stage. Variable groups in Azure DevOps are a powerful feature that allows us to store values like usernames, passwords, connection strings, or application settings in a central location, making them available across multiple build and release pipelines. So instead of hard-coding sensitive or frequent values into each pipeline, we can define them once in a variable group and then reference them wherever they're needed. This approach streamlines configuration management, reduces duplication, and helps maintain consistency across projects and environments. Now let's take a look at multi-stage YAML files. Deployment strategies allow us to use specific techniques to deliver updates when delivering our application. Examples would be things like enable initialization, deploy an update, route traffic to the updated version, test the updated version after routing the traffic, or in case of failure, run steps to restore the last known good version. So you can achieve this by using lifecycle hooks that run steps during the deployment. The lifecycle hooks in Azure DevOps deployment jobs are special steps that automate and control each phase of the application's deployment process. So we think of them as checkpoints that ensure everything happens in the right order and with the right safeguards. For example, the preDeploy hook runs tasks to initialize resources before the deployment starts, setting the stage for a smooth rollout. The deploy hook handles the actual deployment of our application, including downloading necessary artifacts, unless we specify otherwise, or once a new version is ready, the routeTraffic hook directs user traffic to it, and the postRouteTraffic hook monitors the health of the updated version for the set interval, making sure that everything is running as expected. If something goes wrong or everything succeeds, the on-failure or on-success hooks kick in to handle the rollback actions or the cleanup, keeping our environment stable and tidy. The runOnce deployment strategy in Azure DevOps is the simplest way to automate application updates, ensuring that each step in the deployment lifecycle happens just once in a defined order. This strategy executes all the key lifecycle hooks, preDeploy, deploy, routeTraffic, and postRouteTraffic sequentially. First, resources are initialized, then the application is deployed, followed by routing user traffic to the updated version, and finally monitoring the health of the new release. And then once that's done, the process concludes with either a success or failure hook, which either then runs the cleanup or a rollback if it's needed. This approach is straightforward and ideal for deployments where a single atomic update is sufficient. Now, rolling deployment is a strategy in Azure DevOps that gradually replaces instances of the previous version of an application with the instance of the new version. Instead of updating everything at once, rolling deployments update a set number or percentage of the servers at a time, which is controlled by the max parallel setting. This approach helps minimize downtime and risk, and only a portion of the system is updated at any given moment. If something goes wrong, it's easier to catch issues early and prevent them from affecting all the users. The deployment process is organized into lifecycle hooks, preDeploy, deploy, routeTraffic, and postTraffic, each handling the specific phase from initializing resources to monitoring the health of the new release after traffic is routed. The canary deployment strategy in Azure DevOps is an advanced technique used to minimize risk when rolling out new versions of applications. Instead of updating all the servers at once, canary deployments start by releasing changes to a small subset of servers, like sending a scout ahead to test the waters. As confidence in the new version grows, the deployment expands incrementally to more servers, gradually routing more traffic to the updated application. This approach allows teams to monitor performance and catch any issues early, ensuring that problems can be addressed before the impact of the entire user base. And the strategy is configured using the canary keyword, with increments specifying how many servers are updated at each phase. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch the other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn.